And here we are. It is not Christmas time. Although technically it is still Christmas time because Christmas goes until January 6th, which is indeed the 12th day of Christmas from the song. But not really. All right. So we are here. We are on page 156 for you guys, I believe. Yes, you have parallel and perpendicular line slopes drawn with dripping marker font. Okay. So, first thing we're going to do is draw two lines that are parallel. What does parallel mean? What? They're never ever going to cross, are they? Okay? Everyone agree? Okay. So everybody over here on your graph here, put a point somewhere in the negative x-axis. It doesn't matter where. I'm putting mine there at 1, 2, 3, 4, 5, 6, 7. Negative 7. You can put it anywhere you want. I'm putting it at negative 7 because I like 7. Then put a dot somewhere on the positive y-axis. I'm going to put mine at 4. 1, 2, 3, 4. Then connect the line and tell me the slope. Whatever your slope is. My slope is going to be 4 over 7, isn't it? The m of line 1 equals 4/7 for me. Most of you have probably copied mine anyway. That's fine. That's okay. But if you haven't, you should have a slope here, yeah? Now, if the line is parallel, then I'm going to take a red line, I'm going to put a dot at positive 7 and negative 4. And those lines will never touch, will they? Why? Because the slope of line 2 is also 4 over 7. All I did was slide it along and drop it down. Everyone understand? If the slopes are the same, they can't possibly touch, can they? If they're lines. Because where's the next dot going to be on the black line? Where's the next point I can put on this? It's a line, so the x's and y never changes. Where's the next one going to be? 7 over and 4 up, right? Where's the next red one going to be? 7 over and 4 up. And they're never ever going to touch because they go on forever. That's what makes them a line. They move the same amount right as they do up forever. Everyone cool? So, if in math class we just drew two parallel lines and we can see that the slopes are the same, what does that tell us about every parallel line? What does that tell us about the slopes of parallel lines? They're always the same. Everybody cool with that? And that makes sense. If the slope were changing, they would cross eventually. These are never going to cross. Everybody good? Okay. Now, next one is perpendicular. Now, perpendicular is a little bit weird. We're going to draw two lines for that, okay? The first line we're going to draw is a vertical line through somewhere on the x negative, okay? So draw a vertical line anywhere through the x negative spot. The slope of line 1 is what? What is the rise over run for a vertical line? The rise is, how far up does this line go? Where's that line going to go? Infinity. So its rise is infinite. What's its run? 0. That's not allowed, is it? Everybody understand? We know that that's an undefined slope, right? Because we're not allowed to divide by 0. Everybody cool? All right, now take another line and draw it straight horizontally, crossing your first line anywhere you want. What is my m of line 2? What's my slope of line 2? It's still rise over run. What's my rise? 0. And what's my run? Infinite. What do you notice about those two slopes? Pardon me, Caitlin? They're opposites. They're actually reciprocals. They're not opposites. They're reciprocals. Well, it's not the same thing, but if you need to remember it that way, that's fine. Is everybody cool with that? You can all see that that is the case, yes? Everyone agrees? Okay. Now we got to do something slightly different. Draw another line through 0, 0, and go out to 5, 5. And make that line. What is the slope of line 3? 5 over 5, right? 5 over 5. Cool? Now, do line 4, put the dot at negative 5, 5. And make that line. What do you know about this angle between line 1 and line 2 and this angle between line 3 and line 4? Remember, I'm only talking about the angles right now, Antonio. They're 90-degree angles, aren't they? That's what makes them perpendicular. Everybody cool? Perpendicular means they meet at 90 degrees. If you don't remember that, I'll just write it here. They meet at 90 degrees. Now, what is the slope of line 4? Rise of positive 5 and a run of negative 5. Everybody cool with that? Everybody's okay with everything we've done here, right? Now, please notice two things have happened with perpendicular lines, haven't they? The first one told us perpendicular lines have to flip. They're reciprocals, yes? The second thing that happened told us that one of them has to be negative. Everybody with me? So what does that mean if this happens and we get a flip, and this happens and we get a negative? What's going to happen if it's not a perfect one like that? Like my two examples here. What if I have a line that goes like this? Don't write this one down. What if my lines meet like this? Oops, that wasn't a very good 90. What is going to happen here? When it was this one, they flipped. When it was this one was negative and one was positive. What do you think happens over here where it's not perfect? One thing will happen, two things will happen, or both things will happen. What do you think? You know. What's going to happen? You can see this one has a positive slope, can't you? Right? And you see this. And you can see the other one has what kind of slope? A negative slope. So you know, oh, that's lovely. That's new. I'm not running another instance of OneNote. So you could see with that third example I drew, this one over here, one of the slopes is positive, one of the slopes is negative. So that covers this one, doesn't it? But you can also see that this guy goes up and over, and then this guy's run and rise are very similar, aren't they? As a matter of fact, both things will happen. The slope goes to the opposite slope, negative, and it reciprocates. The rise and the run flip. Everybody good? So what are the two things we have discovered today? Parallel lines have equal slopes. Because the rise over the run cannot change. And perpendicular lines have slopes which are negative and reciprocal. Oops, good spelling, Myers. Now, this is what that means. Line 1 has a slope of rise over run. Agreed? Everybody understands that that's every slope, right? If line 1 has a perpendicular buddy, that is line 2, then what will line 2's slope be? It will still be rise over run for line 2, but how will it compare to this one? It will be the run over the rise and negative for line 1. Does everybody understand what I am saying? The slope of line 2 is still rise over run if you were counting it by itself. But when I compare it to line 1, whatever number was here in the numerator spot is going to be a denominator. And whatever number was in the denominator spot moves to the numerator when you compare the two. Does everybody understand what I'm saying? I am showing you this because a lot of kids don't make the connection between these numbers as being the same. Okay? I'll show you what I mean right now. The first slope is 2/3. So the line 1 has what slope? 2/3. And that is a rise over a run. Everybody with me? What will line 2's slope be? Almost. Right. -3/2. The numbers are the same. You flip them and you change the sign. Now here's where this gets confusing for people. If I sketch this, line 1 goes up this way, right? Line 2 is going to go this way. Now line 2 has a slope. Line 2's slope we still find by doing rise over run. But you're going to find that it has the same numbers. Everybody with me? We would find the slope the same way, and it will have the same numbers. I must restart my computer now. Screw you. All right. So, my line 1 in example number 2 has what slope? -7. over 1, right? Okay. So what's the perpendicular line going to be? Perpendicular line to is what? 1 over 7. They flip and we change the sign. Is everybody good? Okay. Parallel, what's the parallel slope? 4. Absolutely. Third line. First slope is negative 5/11. What's the perpendicular slope? 11 over 5. Slope of 0. Undefined, because it's a vertical slope, yes? Line 1 is flat, no slope. Line 2 is vertical, infinite slope, which we're not allowed to have. And then, this one's just the other way around. Line 1 is undefined, it's vertical. Line 2 is flat. Is everybody good? It's nothing new, right? It's just slope again. So, this next question. I'm going to write a very large message to you at the top of this page. When in doubt, find slopes. In this unit, if you're like, oh crap, I really don't know what to do here, find some slopes. You almost always need them, and that might tell you something, okay? So this question says, are these two lines parallel, perpendicular, or neither? If they're parallel, what will their slopes be? Right, if they're parallel, m will equal m. If they're perpendicular, m will equal negative 1 over m, won't it? And if they're neither, the slopes will have nothing in common. Everybody got it? All right. So I want to see if ST is perpendicular to AB. So how many slopes do I need to find? Two. I need to find the slope of AB, and I need to find the slope of ST. How do I find those? Do I have a graph? So what do I have to use to find slope when I don't have a graph? Y2, Y1, right? So I got to do AB first. What are the points I'm going to use for AB? Negative 1 minus 1 over 5 minus 1. Is everybody okay with that? Did I have to do them in that order? Who chooses what's x1 and x2 and y1 and y2? Who chooses that? You do. So that is negative 1 minus 1 is negative 2. 5 minus 1 is 4. Negative 2 over 4 is negative 1/2. Everybody agree? Any problem with that? Okay. What's the slope for ST? Five minus 1 over negative 1 minus 4, which is 6 over 3, right? Which is what? 2 over 1, positive. Negative 1/2, positive 2. What are these things? They are perpendicular. Everyone see how to do it? It's easy peasy, right? I got me a triangle. Is it a right triangle? I don't know. Is it? If it's a right triangle, what does that mean? That's somewhere in the triangle there's a 90-degree angle, yeah? Now, how many angles are in a triangle? 3. So I would need to check all 3 intersections, wouldn't I? Wouldn't I? Does that really make sense? Does it make sense to check all 3? It could, but if we sketched this, would that narrow it down for us? Would it? Let's sketch this triangle. Negative 3, 1. Where's negative 3, 1? He waited patiently for his grade 10s to tell him where to put a dot. Everybody happy with that? Okay. Where's B? And up 2. Down 2. Everybody agree? And where's C? There's C. Now make the triangle. Now we just sketched it, didn't we? So it's not going to be exact. But do I really need to check all 3 angles? What's the only possibility, A, B, or C, of being 90 degrees? It's the only one I got to check, right? I only have to check there, correct? So I got to check if the slope of AC is perpendicular to the slope of BC, right? Right? Well, let's check. What's AC? I got to use A. Oh, I should do it in red. I got to use A and C first. So what's the slope? 4 minus 1 over 3 minus 3, which is 4 minus 1, 3 over 6, which is 1/2. Everybody cool? Okay, what's BC? I got to use B and C now. What's that? 4 minus 2 over 3 minus 6. What's 4 minus 2? 6. What's 3 minus 6? Negative 3. That's negative 2. Are those perpendicular? Yep. So is this a right triangle? Everybody good? All right. You got 20 minutes left. Yeah, I don't want to do that yet. Spend some time with page 349. It's useful because you will be doing lots of slope practice, and you need lots of slope practice. Oh, wait a sec. Do you guys have more of this? Oh, I'm an idiot. I was looking at a different set of notes. Now you got 2 more to do. I thought we were done a little early. So this is page what? 157, right? 158. So I got 4 points. I need to do parallel. What do I know if the lines are parallel? What do I know? That the slopes are going to be the same, right? So if it's parallel, the M of AB must equal the M of CD, yes? Everyone agree? So AB, y2 minus y1 over x2 minus x1 must equal the same one over here, right? y2 minus y1 over x2 minus x1. So all we do is we fill it in. What's AB? 10 minus 5 over 7 minus 3, correct? And the other one is A minus 2 over 1 minus 0. Everybody still agree? Now we just solve it. 5 over 4 has to equal A minus 2 over 1. Yeah? Then we just solve it. 4A minus 8 equals 5. Right? 4A equals 13. What does A equal? 13 fourths, or 3.25. Now that bothers people. Why? It's a decimal. But don't decimals exist on graphs? So is it okay? So are we good? Parallel's easy, right? The lines are the same. What's the next question? I'll leave that there for a minute. You can check that later. What does perpendicular mean? The M of AB, if it's perpendicular, the M of AB equals what? It equals rise over run, yes? We also know that the M of AB is what? Isn't it 5 over 4? Is everyone okay with that? I want a perpendicular line. So what has to happen to 5 over 4 if I want it perpendicular? Right. I have to negative reciprocate. So what's my new slope that I need? Negative 4 over 5. Did the other side change? Did the other side change, or can I leave it? The other side has to have that slope, doesn't it? So the M of CD has to equal negative 4 over 5, doesn't it? So the M of CD is y2 minus y1, isn't it? So what was it? It was A minus 2 over 1 minus 0, wasn't it? So it's 5A minus 10 equals negative 4, right? Then I just solve it. 5A equals 6. A equals 6 fifths, or 1.2. Is everybody okay? Does everybody understand what I did here? This is about the hardest thing in this unit, I find, for my students, to understand what we are doing here. Does everybody get it? Because I'm looking for perpendicular, I can take the slope I had and flip it over. Could I also have flipped over the other slope? could I have done this? And I'm not saying to do it, but could I have done this? Could I have left 5 over 4, but taken the other slope right here and flipped that? Because that's a minus 2 over 1, right? Could I have flipped this to negative 1 over a minus 2? Could I have done that? Would I get the same answer? 4 times negative 1 is negative 4. 5a minus 10. Please notice it's the exact same thing. All you have to remember is when you have a perpendicular slope, you have to flip and negative one of them. Everybody good? Okay. Now, please have a look at page 349. Sorry about that, guys. My head was in my bum.